triangle exterior angle theorem, and we looked at the triangle exterior angle theorem last 6 weeks, but your corollary is basically a relationship with the theorem that proves the theorem to be true, or shows that they um, correlate with each other. Okay. Um, the exterior angle theorem says if I have an exterior angle theorem, whatever exterior angle theorem I have outside the triangle, it will always be greater to each of the remote interior. So angle 1, what they're showing you here, angle 1 is the exterior angle. It is greater than angle 2, and it's also greater than angle 3. It will always be bigger than the remote interior. Now, the exterior angle theorem states if I'm doing the theorem, if I use the theorem, then I should know, and this is what we looked at last 6 weeks, that angle 1 equals angle 2 plus angle 3. So if I'm just looking at just one of them, then that one has to be bigger than each remote interior. And we're going to practice on proving it or being able to explain why. So who is the exterior angle in the first example? Angle 1. Okay, so angle 1 is our exterior angle theorem, or exterior angle. We're trying to explain why it would be bigger than the measure of angle 2. Okay? So, do we know who angle 1 is greater than? Yes, it's greater than 3 and 4. Okay, so the measure of angle 1 is greater than the measure of angle 3, and we know the measure of angle 1 is greater than the measure of angle 4. Okay? Greater than both. All right, so do we see any other relationship? Yep, 2 and 3 are vertical, so we know that they are going to be what? Congruent. All right, so we know the measure of angle 2 is congruent to the measure of angle 3 because they are vertical. All right, there's a symbol, and I'm going to try to make some space for it. Whenever you see 3 dots in the form of a triangle, that means therefore. This is what we use when we're trying to come up with our conclusion. Okay, we use that symbol, and we're about to draw a conclusion based on what we know. All right, so therefore, what could I say? Since I know 2 and 3 are congruent, what can I say about 1 and 2? Yeah, angle 1 is greater than the measure of angle 2. Okay? Using what we know about angles and their relationships, I can come up with a conclusion for the figure. So, again, they want us to compare the measure of angle 1, okay, which is our exterior angle, with the measure of angle 2. And we want to come up with a relationship. See if we can use previous knowledge. So anything you know right now. 3 and 4 are alternate interior? 2 and 4, yeah. 2 and 4, I can say that because we got parallel lines. All right, so 2 and 4 are alternate interior. Okay. 3 and 2 together would equal 1. That's correct. Okay. So if I was to put these together, they would equal angle 1 because they are also alternate interior. Do y'all see both pairs of alternate interior? All right, so see if you can come up with a way explaining why 1 is greater than the measure of angle 2. Discuss it with your group right now. See if you can come up with, there's more than one way to get this. All right, who thinks they can explain or put why angle 1 is greater than angle 2 for number 2 up on the board for some points? Okay. All right, Vincent, let's go. Okay. All right, we got so measure angle 1 is greater than measure angle 4. Angle 4 and 2 are alternate interior, therefore measure angle 2, or no, angle 1, excuse me, is greater than the angle 2. Yeah, that's the one. That is correct. Okay, that is correct. Anyone do it a different way? Did everyone see that relationship? Where you got that? Good job. All right, so, good job. All right, we got a different way. Let's go. Yeah, you can. All right, so he has the measure of angle 2 and 3 equals the measure of angle 1. Therefore, the measure of angle 1 is greater than angle 2. That is true as well. Okay. All right, I went ahead and put your points on there. All right, so do we have questions on how to use the exterior angle corollary in relationship to the remote interior? All right, the next part. All right, we're going to start getting into triangle inequality theorems, relationships that occur within triangles. And the first thing I want you to make sure you can see, our first theorem states that two sides of a triangle are not congruent. They're not congruent. They have to not be congruent. Then the larger angle lies opposite the larger side. All right, can y'all, I try to highlight these different colors because I wanted you to see that side XZ, this side here, can you physically see that that's greater than XY? You can physically see that. Y'all understand that? Okay, all right, so we know that XZ is the bigger side when I'm comparing the two. All right, now, with that being said, if I'm looking at this one is the larger, this one is smaller, okay? All right, so what you have to do is you take that side and you have to look opposite the side to see its corresponding angle. So if I go opposite XY, that would be angle Z. Do y'all see that relationship? What angle is opposite XZ? Y, okay? All right, so since XZ is the larger between the two, then I know that angle Y would have to be larger than angle Z, okay? Because it's opposite the larger side. Does that make sense? You have to look opposite. So you might want to put a little side note to look opposite or across. To find your angle. So they want us to list the angles of the triangle from smallest to largest. So if I'm physically looking at the sides, okay, which side it looks the smallest? CE. Okay, so we can physically see this is the smallest side. All right. All right. Which side looks the largest? Yeah. So this is our largest. And then this would be our mid, right? Okay. All right, so they want us to list our angles in order from smallest to largest. So I have to go opposite that side, CE, and what angle would that be? Angle D, right? So we have angle D, that's the smallest. Then what's going to be the middle angle? Angle C. And then our largest angle would be 105, which is angle E. Are we good with that? Now, on number 2, notice that there's no triangle given to you. So guess what you need to do? You need to draw it and label it. So try to draw and label so you can figure out which angles are the smallest from, or put them in order from smallest to largest. All right, hopefully we're drawing a triangle. Oops, forgot this one doesn't work. We just need to label it X, Y, Z. And we know X, Y is 12. It might not be drawn to scale, but we're just going to get labeled. YZ is 24. And ZX is 30. All right, so they want, based on the side measurements, the angles list from smallest to largest. So what's our smallest angle? Angle Z, then angle X, then angle Y. Questions on that? Okay, all right, now this theorem is pretty much, we can go vice versa. So I'm talking about sides, I can also talk about angles. So on the next page, theorem 511, it's theorem 510, but it's basically angle inequality theorem, which will angle, what is it? Measurement theorem, because we're going to look at inequalities on the next part. All right, so what if I talk about the angles? On this, it's just saying, before I gave you the size, what if I, now I'm just going to work a little bit backwards. It says if two angles of a triangle are not congruent, then the longer side is opposite the larger angle. So it's just the same relationship, but now I'm starting with the angles, and now you're going to give me the sides. So it says if the measure of angle A is greater than B, okay? This one's the small one. This one's the large one, okay? So if A is greater than B, then if I look opposite the angle and go to the side, so opposite angle B is side AC, and opposite angle A is side BC. So then BC, side BC is also going to be greater than side AC. We're just going to do the same thing, but now I'm starting with the angle. So we're going to put our sides in order from shortest to longest. So we know that this is 28 degrees, 110. Could we find our missing angle H using what we know about triangles? Yes, okay. What's the measure? You know? What is it? The missing angle? Yeah. What's the measure? Right there? 42. All right, so we got 42. All right, now we can compare them. We see now which angle is our smallest angle. G. Okay, so this one's our smallest. And the 110 is obviously our largest. So now we want to list the sides from shortest to longest. So I have to look opposite that smallest angle to find that side. So which side is the shortest side? FH. So we start off with FH. That's the smallest side. Then we want the middle side, GF, because the next angle would be 42. And then the largest angle was 110, so the largest side would be GH. And that's all we're doing. We're showing the relationship between the angles and the sides and being to list them from shortest to largest, or vice versa. All right, so number 2 is like we did before. No picture given, so you need to draw and label. Anyone have the sides in order from shortest to longest? Looks. We have EF. Okay. All right, then FD. Okay, or DF. Yeah. All right. ED. That is correct. All right. Any questions on that? Are we okay on that? All right. So with that being said, this is just probably putting it all together. In a triangle, if one side is longer than the other side, okay, then the opposite, the longer side is also the opposite, the shorter. The opposite angle is also greater than the opposite side of the shorter side. So they just go together. So remember this part. Always this happens. The biggest angle is always opposite the biggest side, and you can work down from there. It's the same thing about it if I start with the side. The biggest side is always opposite the biggest angle, and you can work down from there. That'll always be a relationship. So now we're going to put it in, I want you to start this example because this is how you would be tested. Okay. Just put the sides in order from greatest to least in triangle ABC. If the measure of angle A is 3x plus 20, angle B is 2x plus 37, and the measure of angle C is 4x plus 15. So no picture will be given. You would be expected to draw a triangle, label it ABC, label the given angle. So we know angle A is the 3x plus 20. We also know angle B is the 2x plus 37. And angle C is the 4x plus 15. And from that, given information, we have to be able to set up a problem to help us problem solve and list our angles from our sides from greatest to least. So after I labeled it, what do you know? What are we going to use? Yeah, triangle sum theorem states I can add them all up and equal to 180. So we're going to have 3x plus 20 plus 2x plus 37 plus 4x plus 15 equals 180. You have to do that first. So see if you can simplify the equation and solve for x. Alright, hopefully when you worked it out, we got x equals 12. Alright, but now I got to use that to find each angle measurement. So what's the measure of angle A? Angle A, hold up. Yeah, 56. And then B, and then C, 63. Okay, so now we can determine our sides from greatest to least, which is our biggest side. AB, hopefully, because angle C is our biggest angle. So it goes AB, then AC, then BC. Questions on this? Any questions? All right, now we're going to take that fact, understanding the relationship between the biggest angle and the biggest side, and use it with coordinate geometry as well. So put the angles in order from greatest to least if the vertices of the triangle are given. So you got to plot it, and then we got to look at the lengths of the sides. So first, let's get our triangle plot. -4, 2 is J. We have 4, 3 is K. And 1, -3 is L. All right, so how am I going to determine which angle is the biggest angle? What is needed to determine that? Close, close. What do you need in order to determine the angle measure? Huh? No, not the midpoint. We need the distance. We need to know the distance between each segment or each point. Okay, so you need distance or you can use the slope with the Pythagorean theorem. Alright, so let's start with JK. Alright, we want to find that distance. How would y'all like to do it? Are we going to do distance formula or are you going to use slope? Alright, distance formula says we have to take x2 minus x1 parentheses square plus y2 minus y1 parentheses square. Alright, so if I'm using J and K, we got to plug it in. Alright, what's our x's for J and K that we're going to use? Yeah, 4 and a negative 4. So 4 minus a negative 4, parentheses square, and then we got to do the y's. So there'll be 3 minus 2, right? Parentheses square. Alright, what's 4 minus a negative 4? No. Positive 8. So we're going to do 8 squared and 3 minus 2, 1 squared. Alright, so we got to actually square it before we can take the square root. So 8 squared would give you 64 plus 1, square root of 65, which is approximately what? Huh? Yeah, it is 8 point something, yeah. What is it? 8.06, okay. Alright, so now that's JK. I'm going to put 8.06 here for JK. So we have to do the same thing for the segments or the sides KL and JL. Right, are we going to still use the distance formula? Or do y'all want to do a different one? Okay, you want to try it for that. Alright, slope. Alright, so let's count. Our rise over run. Oops, I went up too far. For from K to L. How many units? 6 and 3. Okay, so basically I'm going to do 6 squared plus 3 squared. Since my rise was 6 and 3, I'm going to do 6 and 3 using Pythagorean theorem. Alright, so that basically is going to give me 36 and 9. What's 36 and 9? 45, so I'm going to take the square root of 45, which is approximately what? 6.7? Alright. Alright, so that lets me know that this side, KL, is 6.7. I can do the same thing with JL. See if you can find the length of JL right now. You can use your slope if you want to, and Pythagorean theorem, or the converse of Pythagorean theorem. So, alright, JL. Oh. Alright, what was the length of JL? Anyone get that one? 7.07. Okay, so now we see which side is the biggest. So what's our biggest angle? So it should angle L, then it should go K, and then J. Okay? Alright, now, I'm hoping y'all see the relationship, because now it comes some problem solving. Go ahead and star this example and this next one. And I'm going to let you see if you can determine which sides are, put them in order from greatest to least, but we're talking about the quadrilateral for this problem. Okay? Quadrilateral A, B, C, D. Yes, you can use your triangles to help you problem solve, but make sure we're putting the quadrilateral sides in order from greatest to least. So try that right now. Just try. Take a risk. All right, can anyone identify at least the largest side? Yeah, okay. Here's my angle 71. AD is part of the quadrilateral, so AD is my largest one. All right. Now, I'm assuming that you're saying the next largest angle is the 60. All right, and we can see that goes across to DC, which is part of the quadrilateral, which I can use. All right, which angle did y'all go after that? To the 59? Yep. So we got AB, which is part of the quadrilateral. And then if you just keep on going in chronological order, I guess for the angle measurements, we would next go to 50, correct? All right, so if I go to this 50, it's going to segment BD. Is BD part of the quadrilateral? No, it's in the interior. I can't use that. So I have to use this 50, which would make that BC. Okay, now, I want you to pay attention to this and this, okay? We have 50 going to BD, and we have 70 also opposite of BD. All right, so what does that tell me about this segment here? Is it the biggest? I mean, is it related? I mean, why not? Why? One is not a side, okay? It's in the interior. It's not a side of the quadrilateral, okay? And it has a different relationship depending on the triangle you're looking at. If I separate them, and I'm looking at this, just the triangle on the left, then now it has the smallest side correlation, right? If I separate them and I'm looking at the triangle on the right, now it becomes the biggest. But once I put it together and it comes in the interior, it now becomes irrelevant. I cannot use this interior segment, okay? I'm dealing with the quadrilateral. All right, so if you understand that, we are going to get the next one right. Okay, if you understand that, you're going to get the next one right. I want you to try the next example and check with your group members that you have it right. Once everyone in the group has it, I'll come by and stamp for points. Real quick, this is what we call the triangle inequality theorem. And we'll finish this. What time the bell rings? Okay. Alright, the triangle inequality theorem states that basically the sum of the length of any two sides of a triangle is greater than the length of the third side. So I'm just going to, we can name a side also with a lowercase letter. So I'm just going to put A, B, and C. Okay? Just A, B, and C. Alright, so basically, if I'm looking at C, the theorem says that the sum of any two sides, so if I add A and B has to be greater than the third side, C. That works for all sides. So I could also say B plus C would have to be greater than A. And then I would also have to check that A plus C is greater than B. It has to work for all three. All three must be true. Okay? All three must be true. Okay? For you to have a triangle. And we're going to stop with that. Okay? We're going to stop with that. No homework tonight. Okay?